Good evening, good afternoon, or probably good morning to all the participants. This challenge started, getting into place with a lot of discussions between the IEEE Public Safety Technology Initiative team and Testbed Committee, as well as the IEEE MOVE Truck program led by Graham Randall, who is also today. So the idea is that we want to utilize the technologies developed in the last, several years, especially in the AI machine learning, together with all the data science related technologies in developing in the last, several decades, to explore the data collected by the router on the truck. So there are mainly two challenges here. I put it three here, mainly because the last one might be something that when you're doing the first two. The very first challenge pillar that we are targeting is the anomaly detection, which is a pretty standard, data science task when you're dealing with a data science project. Many times you'll be asked to detect some anomalies happening in the time sequence, or in sensor data that you might be working on. So another challenge is on the geospatial analysis. We'd like to ask our participants to explore the map signal coverage across disaster affected areas. So essentially, when you have this disaster happening, it's very likely that some cellular towers might be failing, and people got affected might not have the network connection, mainly because of those infrastructure failures. Being able to identify those failures and leverage the information you learned from the data, you might be able to help optimize those distribution of those cellular tower. But of course, the current cellular tower distribution is highly linked to the highways, and you may see from the maps, and also linked to the infrastructure already there. But there might be some potential needs, and for certain areas, and you want to have extra or redundant tower installed just in case of emergency. So this gives the community, which will likely be affected by disaster like hurricanes or earthquakes, some extra redundant connectivity that whenever it's needed. So in recognizing the final winners of this competition, so the IEEE MOVE Truck team, as well as the IEEE Public Safety Technology Initiative, so we are putting together several prizes. In this case, we have three prizes from first, second, and third. But the finalists getting invited to the final competition during the conference in September this year will also get some souvenirs for participation, and some more details will be announced later. So the final recognition and presentation will be held at the 2026 IEEE World Forum on Public Safety Technology. So since it's an international challenge, we actually didn't put any constraints on the publication teams, at least based on the announcement we put on the website. But there will be some export control constraints about certain data types and certain data you might be using. So fortunately, all the participants, in this competition, we haven't seen any participants from those countries in the entity list that U.S. Department of Commerce put out a while back. So far so good. So we don't have any constraints for this competition. And the team size, we ask the participants to team up with up to 4 members. Just in case if you have more members, it's kind of harder to move forward if you have a big team. But we do want you all to figure out where to team up so that you can get something more done, instead of just being yourself, which might be some burden to some of you. We don't have any particular requirements other than the ages here. You need to be 18 years old for you to enter this competition. And that's the common rules that required for any competitions with a prize there. For the registration process, we have already finished this one. It's the last day of the registration is January 31st. It's already passed. For the judging panel, we have assembled a team already. So the full list will be announced through the email or on our website. We'll probably do both. So we have people with data science background, and we have judges from telecommunication companies and IT platform companies. We have also disaster response, from IEEE MOVE Truck team, and also we have folks from the FirstNet joining us to help us evaluate the submitted competition materials. So again, as I mentioned, we have two big tasks here to compete. One of them is about anomaly detection. So we'll essentially evaluate the precision and recall, and also there are other scores we can look into, but these are the two most important factors. And this could be presented in the submitted materials, and the judges will look into the data as well as any source code that you are willing to share. In most cases, we do ask the team to submit with their source code or Python script that we can evaluate on our end to make sure that you got what you claim you got. And the number two is about optimization plan efficiency. In this case, we'll evaluate based on the cost efficiency and mostly coverage per dollar. If you want to have a new design of the cellular network, we do need to evaluate if it's really a cost-effective way. And price is one of the major concerns for engineering projects in many of these kind of projects. Another one, of course, is signal quality. So all this will be put together, including the infrastructure, that the number of towers. If you have less number of towers, put into those strategic locations, and requires much less cost than many other plans, your plan will be highly ranked. So it's a combination of all this together. It's like a trade-off. There's no way that you can get all this. It's always a trade-off. But we'll find the plans that give us a maximum benefit across all these three categories. For the timeline, we'll kick off the competition today at our webinar, and the results will need to be submitted from the participants on June 1st, 2026. Since it's an international competition, it will be end of day anywhere on Earth, as long as still June 1st on your local calendar, you're okay. June 16th will be the days for the finalists selected. We'll select at least 5 or 5 to 10, that's depending on this, some budget we're still trying to figure out, and there are many other things still need to be considered. But we'll select the finalists on June 16th. The total size needs to be determined later on. And these are the pre-conference phase. And starting from September 22nd, we'll be at the conference phase. That's starting from 22nd and ending on 24th. We'll ask the finalists to present, and then we'll ask our judges to go through these materials, and then we'll have some extra discussion about within the panel, and we'll also offer the opportunity for the finalists to present. And finally, we'll have the awards ceremony, and we have some closing remarks, etc. So that's during the conference period at that time. That's a conference phase. So now getting into the real materials for today's kickoff. For the datasets, as I mentioned, the datasets, it's a raw material downloaded from the router, installed in the truck. So my team, actually me and my students, were trying to keep this raw data collected by Grayson Randall's team. I think mostly done by David Green, and he's the one collecting data and then share data with us. So my team took a look at the data and make sure all the JSON files are readable. So we put it to the Google Drive. So I'll share the slides right after my presentation, and all the links will be available on this slide deck. So you can clicks the button and downloads the data directly over there. So it's a signal, all the signal metrics, including 4G, 5G signals from essentially two network providers. One of them AT&T, another one is Verizon. And we have a GPS tracking information as well for all the signals, and you know exactly where you are for every detection. And the reference signal tower measures the usable downstream signal strengths for 4G LTE, and that's will be also in the data set. You have also received signal strengths also in the data set. But all these are in the data in the raw format. So actually, my students already cleaned up a sample data set. The data set you have, I'll show you in a second, contains two. One of them is a very small set. We call it sample data set. We show you how the data set looks like, and then we have a very simple, a cleaned up data, show you what the signals contain, what the information contained there. Another data set with a raw full data set contains all the information and for the competition. And that's the one we didn't get into details, but we keep the raw format. So part of the work, essentially, it's about data engineering. And you need to look at the data and do some EDA, exploratory data analysis. If you don't know the term, and it's essentially a way for you to visualize and clean up the data, make sure that you see certain patterns visually, and then you start looking into the ways how to do some further analysis. That's called EDA. And after that, you can start, if you want, you can building models and make predictions. You can also do statistical analysis or geospatial analysis. There are multiple ways you can look into the data. But again, the data is in the raw format, and some extra work will be needed. It's not a clean data, just like, no, not like the data you download direct from Cargo or some other places. It's cleanly, it's not in CSV format, it's in JSON format with a nested structures there. So for the objectives, essentially we have two tasks there, but based on those two tasks, you can do some, for example, statistical threshold analysis, detecting some sounding signal drops, or also if the signal is exceeding some normal range or normal variance, then that's potentially a signal of anomaly, right? Another one is probably detecting the idle period analysis. If the signal is from certain tower getting idle for too long, and that might mean something bad for the tower, or it could potentially be a problem with on the receiver side. But in this case, as far as this competition, in the context of this competition, it's safe to guess that the signal idle mainly because of the tower, and treating that as a potential failure of the cellular tower, which is completely reasonable, in the context of this competition. Instead of assuming that receiver is not working, we assume the tower is not working. And even though it might not be the case, but as far as the competition is concerned, that's a good evaluation. So finally, it's about a distribution comparison. You want to compare some historical data, real-time data. So real-time in the sense that close to the end of the time, we are collecting about 8 months of data, and so you can treat part of that as historical data, and then you can look into some new data. That's up to you to see how this the data fit into the way how you analyze it. So it's considered like a sequential of longitudinal data covering a long period of time. So to the right here, I just show just a demonstrative graph. It doesn't mean anything particularly. It's just showing you if you have different signals, you can see the variation of signal strengths. That's a potential way to look at the data you might be collecting. And you want to detect different signal changes and potential failures based on the signal strengths, etc. So the second one is about the coverage optimization strategy. I also, in addition to the data we provided, I also found a link. Actually, Grace sent me a couple links already. You can download the existing cellular tower information. Mostly it's like location. And also, of course, a vendor. It's AT&T or Verizon, and you know where they are. And you may see actually which tower is failed or which tower failed. You can identify the tower ID. As again, I want to emphasize here is that it's could be the failure of the receiver side, the signal side, or anything might be blocking the information. Might not be just failing of the tower, but in the context of this competition, we assume it's a failure of tower, and some part of the data was purposely masked, just to make sure that you can see some failure of tower. Otherwise, it's kind of hard to get anything interesting from this competition. If everything is working perfectly, then how can you detect all the anomalies, etc. So that's partially engineered into the data set that you can detect something on your. So to evaluate the signal overlapping, which is actually a very common use technique, is to see, one tower, given the tower side and given the potential, coverage of individual tower, you can see some overlapping areas. That's where most likely there is a transition between one tower to another tower. Sometimes you may notice a signal either dropped or there is some discontinuity around those coverage overlapping areas of two neighboring towers. Those are something you need to analyze, and that might not mean the failure of tower, right? It's just a transition from one to the other. And the terrain modeling essentially account for the topology. This is the part already advanced analysis. Some of you might not be familiar with the GIS information system, geographical information system. This height information also, because your signal is sending to for 5G, it's sending to a given direction, and the total distance matters here. So where you are, on the map, it's just give you the 2D information, but you might be, have a tower somewhere sitting in the mountain. So this topology information will be important. That's something might need to dig into some other probably digital elevation models or others into the map service to find out the particular 3D coordinate instead of just 2D, so that you can have a better estimation, not just simply based on the 2D distance, right? So there are some demand hotspots. That's where for example, when you have multiple highways intersecting, or you are in a urban area which have multiple stores nearby, then there might be more central towers just to give enough bandwidth for the coverage. That's where you have hotspots. But in remote areas or rural areas, it's likely that you don't have so many towers covering. You have the redundant coverage in certain areas. That's likely in those remote areas. And the tower sharing is another thing that's when you want to look into how the tower could be used by two vendors. AT&T and Verizon might have their cellular devices on the same tower, which is very likely happening. Some of them towers owned by a different company, and it could be rented out to those carriers. So those are the different scenarios you may consider, but if you really want to get into the simple optimization, it's also fine. These are actually going to give you more realistic information that you can put into some comparison compared to probably more ideal case, right? These are the factors you want to put into consideration, which will be helpful, of course, for you to propose more realistic solutions for this challenge. So for the submission, we do need a pretty lengthy report because I think this is a pretty challenging questions we want you all to help to resolve, and there are some technical details we do want to understand and what you are proposing. It helps for us to evaluate your solution. It also helps to explain your ideas better. So that's why I put like 10 pages, which is pretty long if you don't have so many figures in there. So it's enough for you to explain your technical details and also your analysis in more details. So for the failed tower, you need to submit a CSV file with your identified failed tower with a tower ID, which could be found in a link. That's a tower location data here. I'll share that link with you all. You can go there and download the data for the whole US tower, cellular tower. And the failure timestamp is essentially the time and also the anomaly type. What do you see? And essentially, it's a could be long period of time you don't see any signal from a given tower, then it's likely they just a failure tower. It's either working or down on the receiver side. But sometimes you may notice some deteriorating of the signal strength or other things. So that's also meaning some failure, but it's kind of different failure. So if you can identify those different failure types based on either the deteriorated performance or completely out of the connection, that would be wonderful. So for the optimization side, when we're trying to give us a map for your suggested location of those towers along the road, it will be great if you can send us a JSON file that we directly visualize on our end to see the difference. But of course, if you already have that file, you might have already been able to visualize those on your end, so we can see your report in your report. And it's good to also have a cost-benefit analysis. So estimate, you don't need to know exactly how much it's cost, but the number of tower itself means more or less like the cost in this case. So assuming each tower is costing this much money to install, because that's completely different for different regions. In the urban area and also rural area, of course, the price is different. But this using the number of towers as a cost, it will be already good enough for this competition. For example, if your design or your map requires 5 towers, another team needs probably 3 towers to do something similar. Of course, the 3-tower one will win this case. So the signal heat map could be studied and leveraged. So the easiest one probably is using very simple Gaussian. No, probably not a Gaussian. The distribution is 1 over r squared, and the energy is 1 over r squared. If you do very simple calculation, you can easily estimate the strength reduce significantly. So you can estimate the signal coverage, and then ideally, if you can do a good visualization for the maps that you designed, then the coverage could be easily show the strengths, with certain color maps from red to blue, for example. So we can easily see where are the hotspots where are the places that you have less signal coverage. So that would be great to show in your optimization final report for that. So again, this is a lot of work, but this will be also very good, exercise for those who really want to get into the field, to do some performance analysis, to do some engineering work in the field. That's a wonderful exercise. So for evaluation, essentially we'll be asking you all to give us more, for the anomaly detection. It's very straightforward because we know roughly. Since we did that manually, changed the location, so we know roughly where the failure will be. So you wanted to give us the precision. I mean, you give us the detected and failures, and then we can estimate based on the data we have. So we all do some analysis ourselves to compare with yours, and also we have some manually tweaked information that we can double check those as well. So you'll need to detect, the right, the precision, in the sense that whenever you detect a failure, it's a failure. That's a precision. Then you detect a, failure, but it's not a failure. And then there will be other recall and also other information could be evaluated based on your reported anomaly. And the optimization plan efficiency could be estimated by the coverage per dollar. Here probably is per tower, because we just assume the same amount of money will be used for installing individual towers. So it will be the cost effectiveness of the coverage. And also the signal compliance and how signal strengths and needed to be met in the areas. For example, if you want to cover this highway that are going across different, probably not highway, probably the road, then we needed to make sure that your map covers some main infrastructure, at least in the infrastructure shown in the data we shared in this area. So that's a very important criteria. So we'll do some analysis based on your submission. So you're assuming you'll be submitting your data and your locations. So we can do very quick analysis about that. So finally, it just shows some evaluation weighting. This is essentially for the anomaly detection. One. 25, 25, 30, 50 is 30, 20, and essentially the weight that not necessarily, probably we can do this 25 for all of them, but this is probably taken from one of my previous evaluation criteria we set for another competition previously, but it's roughly like this. So we give them a little bit different scores, or sometimes we can just use the same score for all the evaluated anomaly reported to us. We evaluate that criteria. So the finalist presentation will be at the conference, and starting from September 22nd, we have 3 days one there. If you're able to make it, assuming there might be some extra award to those finalists to support you, but currently it's not clear the budget if we can support that. But it will be we'll figure it out very soon. If you can make it in person, that'd be great. You can enjoy 3 days conference and then join, of course, participating the other all the presentations, and sometimes we might have a workshop and the keynotes. That'll be great. And the worst case scenario is that all the whole competition will be held virtually. We this will make it easier, relatively easier for international participants because it's kind of like expensive to fly to US, and then it might take some time to get a visa, and all this, and could be really a burden for some international participants. But we do want you all, if you can make it, we'll find a ways to get you here to the US to present your work. So the award ceremony will be held towards the end of the conference. There will be one particular event held at the conference just to announce the first, second, and third prizes, and also other people get into the finalists. And as far as the participation benefits, I think this is probably clear. The reason, one of the reasons that I think this is really good is to get to meet and talk with the people all over the world, doing things that everyone really cares. And for students and especially young programmers and young participants, it's a very good opportunity to develop your skills in data science, in communication, and in report writing, paper writing, all this. It's a very good practice. And the networking through these IEEE conferences and this community will boost your potential career path and give you some recognition in the field. It definitely would be helpful. And also you have an opportunity to networking to building network with IEEE experts and with telecommunication community, and also there's a big community in the public safety area that you can get yourself familiar with. So it's another big, network that opens the door to, a lot of career opportunities out there. So I think this already, the registration already passed, so this one doesn't really matter here. So lastly, I want to show you this video that actually my team created for IEEE MOVE Truck a while back. We haven't got a chance to publicize it yet, but this seems to me the perfect opportunity. And while this video is playing, I believe I muted, but just in case it's making noise, I'll mute it. So feel free to unmute yourself and ask questions, since we don't have any coordinator to do that, read your text to me, but you feel free to unmute yourself and ask questions if you have any. With that, I think we conclude the webinar, and on my end, feel free to ask questions. Safe. I think this is not a 4K yet. Let me change this into Well, wait a second. I'm using my 5G. It might not be very good. Let me go back to turn this to lower. I assume the voice is still okay. My network uh, still has my Wi-Fi still have issues. So feel free to unmute yourself if you have any questions, and I'll just open your questions here. I'll just look at the chat room. Anyone?
I have a question about the video. The title was The Digital Twin.
Yes,
Could
that's
you
my team.
explain?
My team is working on digital twins. Oh, you mean the digital twin?
Yes, from the
Oh,
title,
you
I
mean
wasn't sure if
explain
the
the digital
truck, the
twin?
digital twin of the truck, and that's how you made the video.
Aha, yes, yes. So the original plan actually we had when we tried to work on this video was to create a digital twin for the truck. On one end, it's for educational purpose. On the other end, we want to build a digital twin to mimic the truck on our dashboard. So assuming, Grayson's team is driving this to some area. Sorry, let me stop it. Issues here. Um, the ideal case is that we can mimic the way how the system looks like and monitoring the network information on our side, on the virtual side, on the virtual end. So essentially, it's a digital replication of this whole truck, and it gives us a real world, data. I mean, assuming we can get the data from the truck while the truck is driving, and we can help them to identify some failed towers, things like which exactly like what you guys are doing here, and essentially making a digital twin of the truck itself. Does it make sense? Okay, I'm sorry, it's probably some network issue. Okay. Any other questions? I'll send the link of the slides to you all, and then you can go through them separately. And if we have no more questions, we'll conclude the webinar today. And feel free to email me directly if you have any questions. If you have a university address, it's good to have a university address sent to me. Otherwise, it's likely, our university might be putting that into a spam box. It's happened before. So yes. Is there any required template or format started for the report? No, it's just freestyle. As long as you put, we'll have something sent out, just asking some basic information about the team name and participants, etc. But as far as the format of the report, if you want, you can use IEEE transaction, template, but I don't think it's really needed. Some of the students might be, new to LaTeX and Word, so I think it's okay to get a free format. Yeah.
I have a
Thank
question
you for
about the
asking. I'm sorry, go ahead.
I have a question about the geospatial data. If in a disaster, like if I reference geospatial data today, that's not necessarily representative depending on how bad the disaster was. Is
Yes, but I don't think we are for IEEE MOVE Truck, as you probably know, it's not a first responding activity. It's essentially helping with mitigation and relief effort. So essentially, for at least for IEEE MOVE Truck, it's not dealing with that bad situation as far as I can tell. But since it's Grayson still here? No, okay. Oh, Grayson, you can explain probably better than I do, as far as the situation like that.
Yeah, Kathleen, I'm not sure about your question, but um, we collect that data because we have GPS data, is active even when we're in a disaster zone. And whether we can connect to the towers or not is in the data, which towers connect and which ones don't. And so all that information's in the data set.
So it's essentially the latitude and longitude. That's all we have about spatial data at this point. But when you try to do analysis with, for example, the elevation information, those might, as you might say, if you have a huge earthquake, those might be different. Yes. Yeah.
Or lots of wind, the
I'm sorry.
trees will affect the lack of trees will affect the propagation if lots of trees were
Exactly.
knocked down.
Yes.
So
Yes.
I was just trying to get a feel for looking at realism, if it was a bad assumption to use the current propagation environment data, because there are some amateur radio databases that will give you some presumably measured data.
Yes, that's a good point. Actually we haven't got to that far in our case. So we haven't actually really thought about that particular scenario in this case. But again, I think it's a very good consideration for the analysis. Yes. Any other questions? It's great. Okay, let's call it a day. And thank you all so much for attending this kickoff webinar. And I'll follow up with the email with all the information I mentioned today, and you should be able to get started. So hope you all, get a successful competition and enjoy yourself.
Great.
Okay,
Oh,
thank you all so much.
I did
Okay,
think of one other question.
okay, go
The
ahead.
cleaned up data that you have that we can use as example data of what faulty tap, is that already labeled?
So usually, since it's a JSON format, you have more or less like a dictionary in Python. You have all the keys. So for every point, you have some label, essentially. So you know all the numbers, what all the numbers are. You don't need to extra labeling work. It's already very clearly organized in a dictionary format. But that's not cannot be easily, you need to do some data engineering to turn that into some formats that you can easily process with the pandas or some other tools. With that said, the sample data we provided with we have a clean data. You can see how we transform that JSON format into the clean CSV file with some key information that we think might be useful. But for the full data set, there might be some other information that you may consider useful, but we didn't put that into the sample data set. That's some extra work might be needed on your end.
I think I was looking more along the lines of if I'm doing AI or if I'm doing ML, often you want a labeled data set to know to help with the training. Or I
Well, for
have to
this
do the
one,
analysis. Go ahead.
right. For this one, we don't. I actually don't think there will be a much about training the model prediction unless when you try to do some generative information, AI kind of thing, you want to find the optimal location and generate locations, give you some, something relevant. But the data itself already have all the information needed. So instead of labeling, depending on which one you want to put into your target, it's already there. So we know, the data already collecting and showing the values for the particular category. And it's essentially how you organize the data. It's not about labeling, I think. It's all the numbers already
Mm.
have some meaning. So it's just like which one you want to put into the target that you want to start, predicting or do some generation kind of AI work. Um, it's more like a statistical analysis might be more important in this case if you want to do some, network computation and geospatial analysis. Um,
Hmm.
yeah,
Okay, thank you.
sure. Okay, thank you all so much, and looking forward to seeing many of you and the final, events. So take care, and we'll keep in touch through email. Bye bye.
Thank you.